In this video, we're going to look at some more examples of geometric series. The question here is to find the values of x for which the series, the geometric series, converges and find the corresponding sum. For the first question, part A, we have n equals 2 to infinity tan x to the power of n summation. For part B, summation n goes from 1 to infinity log x to the power of n. Part C, we have summation n goes from 0 to infinity, x plus 2 to the n divided by 4 to the n. So let's look at part A first. For part A, we have summation n equals 2 to infinity tan x to the power of n. Now let's find the first term. To find the first term we call it A, just plug in the starting index. The index starts at n equals 2, so plug in n equals 2 and we get tan x all squared. The common ratio, of course, is the stuff in the brackets, the thing that's being raised to a power. So the common ratio r is equal to tangent x. That's the common ratio. So what we have is, we have the first term a is equal to tan squared x. And the common ratio r is equal to tan x. Now for this geometric series to converge, we need absolute value of r to be less than 1, which means we need absolute value of tangent x to be less than 1. That means tangent x has to be less than 1, larger than negative 1. And from the graph of tangent x, we can see that that happens when x is between pi over 4, less than pi over 4, and larger than negative pi over 4. But tan x is a periodic function with period pi. So we need to add n pi to this inequality, period n pi. Sorry, the period is just pi. So x is less than pi over 4 plus n pi, and larger than pi over 4, larger than negative pi over 4 plus n pi. These are the values of x for which this geometric series converges, and the values of n are n equals 0, any integer, 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. So these are the values of x for which the geometric series converges. So let's write the geometric series. We have n equals 2 to infinity tan x to the power of n. This is equal to, the sum will be equal to a over 1 minus r. That's the sum of a convergent geometric series. And a is equal to tan squared x. And the common ratio is just tan x, so we get tan squared x divided by 1 minus tan x, where a is equal to tan squared x. That's the first term of the geometric series. And the common ratio, r equals tan x. And we apply the geometric sum, which is s is equal to a divided by 1 minus r. All right, let's look at part B. Here we have summation n goes from 1 to infinity log x to the power of n. Clearly, this is a geometric series where the common ratio is log x. So the first term will be, just plug in n equals 1, we get a is equal to log x to the power of 1, we just get log x. And the common ratio is the stuff in the brackets, r is equal to log x. All right, so basically we're always looking for this pattern, n equals 1 to infinity, r to the n. That's the pattern of a geometric series. Sometimes we'll put a constant a here, and so basically that's the general pattern of a geometric series. But to be sure that you have the right value for the first term, always plug in your starting index. So the starting index here, if you plug n equals 1, we get a times r to the 1, we get ar. If you wanted to start at a, you actually have to put n minus 1 here to get the pattern right, so that this will actually be the first term, because plug in n equals 1, we get r to the 1 minus 1 is 0, so r to the 0 is 1, so the first term becomes just a. All right, now we need a common ratio, r equals log x. We need a common ratio to be less than 1. That means absolute value of log x should be less than 1. And that means log x should be less than 1, larger than negative 1. And we need to find the values of x that satisfy this inequality, because for these values of x, this geometric series will converge. So we have log x is less than 1, larger than negative 1. How do we solve for x? Well, we exponentiate the whole thing. So exponentiate both sides. So we have e to the minus 1 is less than, every term gets exponentiated, e to the log x is less than e to the 1. So we have e to the minus 1, which is 1 over e, is less than e and log cancel, which gives us x, less than e. So these are the values of x for which this geometric series converges and has a sum. Sum is equal to a over 1 minus r. So we have summation, n goes from 1 to infinity, log x to the power of n. This geometric series will converge for these values of x. For all other values, this geometric series will diverge. But for these values, when x is between e and e to the minus 1, this geometric series converges, and its sum will be a over 1 minus r. A is the first term, which is log x, and the common ratio is also log x. We get 1 minus r, 1 minus log x. And this geometric series has this sum provided that x is in this interval between e to the minus 1 and e. All right, let's look at the last example. Here we have summation n goes from 0 to infinity, x plus 2 to the n, divided by 4 to the n. Now, this is a geometric sum. Let's rewrite this as summation n equals 0 to infinity, x plus 2 divided by 4, all to the power of n. So now we can clearly see that we have a common ratio. The common ratio is simply x plus 2 divided by 4. Let's find the first term. To find the first term, always plug in your starting index. Plug in n equals 0 into the term, so we get a is equal to x plus 2 divided by 4 to the power of 0, and anything to the power of 0 is 1. So the starting term, a is equal to 1. The common ratio is going to be the stuff in the brackets, the thing that's being raised to a power. So r is equal to x plus 2 divided by 4. This is the common ratio. Now, for this geometric series to converge, we need to have absolute value of r, it should be less than 1. That means absolute value of x plus 2 divided by 4 must be less than 1. If we solve this, we get absolute value of x plus 2 should be less than 4. Now remove the absolute value, we get x plus 2 is less than 4, larger than negative 4. Subtract 2 from everything, so we get x is less than 4 minus 2 is 2, larger than minus 4 minus 2 is minus 6. For these values of x, this geometric series converges and has the sum s is equal to a over 1 minus r. For all other values of x, this geometric series diverges. So n equals 0 to infinity, x plus 2 to the power of n divided by 4 to the n converges for these values of x when x is between minus 6 and 2. Now we have to find the sum. So to do that, we have summation n goes from 0 to infinity, x plus 2 to the power of n divided by 4 to the n. This is equal to a over 1 minus r. Well, we found a is equal to 1. We found a common ratio, which is 1 minus x plus 2 over 4. Now, I need to stress this. This geometric series converges and has this sum only for these values of x, for x between 2, x less than 2, and larger than minus 6. For all other values, for all other values of x, this geometric series will diverge. But for these values of x, this geometric series converges. So the sum is going to be 1 over 1 minus x plus 2 divided by 4. Let's simplify this by multiplying the numerator and denominator by 4 over 4. So we get 4 divided by 4 minus x plus 2. So we get 4 in the numerator divided by 4 minus 2 is 2 minus x. This is a sum of the geometric series. So summation n equals 0 to infinity, x plus 2 to the power of n divided by 4 to the n. This geometric series converges for the values of x, x between minus 6 and 2, and its convergent sum is equal to 4 over 2 minus x. So we actually have a closed form for the summation of this infinite series. If you were to expand out this series, it sums up to 4 divided by 2 minus x for these values of x. All right, thanks.